All right, so yesterday we learned how to factor a trinomial like x squared plus 8x plus 12 into the product of two binomials. Today we'll see what to do if we have a trinomial that doesn't have all addition signs. This one we were doing all adding. That made life a little easier. So let's consider x plus 5 times x minus 3. The final answer is x squared plus 2x minus 15. Notice that final number is a negative 15. That tells us that this number times that number, one of them had to be positive and one of them had to be negative. So let's say we got a factor x squared minus 3x minus 10. Well, we're going to do the same thing as yesterday. We're saying, hey, 10. 1 times 10, 2 times 5, 3 times nothing, 4 times nothing. That's it. It's either got to be 1 and 10 or 2 and 5. However, yesterday was easy because it was a positive 10. So we both said, oh, well, they're just positive. We didn't even worry about things. But today we have to worry because it's a negative 10. So one of these pieces must be negative and one must be positive. Now, if you think of 1 and 10, if I said one of them's got to be negative and one's positive, it could be like this. -1, positive 10, or positive 1, negative 10. When I put those together, I get positive 9. When I put these together, I get negative 9. So what we realize pretty quickly is when we're doing this, we just say, hey, one of them's negative, one's positive. That means there's going to be, we need to look at the difference between 1 and 10 giving us a 9. We know we can create either a positive 9 or a negative 9. Well, what about 2 and 5? Well, the difference between 2 and 5 is 3. So we can create either a positive 3 or a negative 3. Now, if you don't believe me, here's 2 and 5. Let's make him negative. That'll produce a positive 3. And we could flip it, put the negative on the 5. That gives you, when you put them together, negative 3. All right? But we don't need to list that every time. That would create, especially if you have quite a few, it creates double the amount you need to look at. So we know that to create a negative 10, you can create either a positive 9, negative 9, positive 3, negative 3. Who do we want? We want a negative 3. So we want this 3 to be a negative 3. Well, I look at 2 and 5 and I simply say, hey, if I'm creating a negative 3, a negative then will have to be on the bigger number and a positive on the smaller, because a negative 5 and a positive 2 will give you the negative 3. So this tells me this breaks down to an x plus 2 times an x minus 5. And you can see right there's the positive 2x and there's the minus 5x, creating our negative 3x. And the positive 2 times negative 5, negative 10. So it's not that much different. So 12. I'm like, okay, 1 and 12. 2 times 6, 3 times 4, and that's it. It is negative, so one of the pieces is negative, one of them is positive, so we just say, hey, what's the difference between 1 and 12? That's 11. The difference between 6 and 2, 4, and 3 and 4, a difference of 1. Now, what do we want to create? We want to create a positive 4, so we're going to be using the 2 and the 6. Now, since we want a positive 4, the positive will go on the bigger number then. Positive on the 6, negative on the 2, because positive 6 with a negative 2 is positive 4. So it's simply x minus 2, x plus 6. And there we have it. That's all the difference that we have to do between today and yesterday. One little piece, though. We have to be a little careful here. We are like, hey, I got 20. Great. 1 and 20. 2 times 10, 3 times nothing. 4 and 5, I need a 9. It looking like the 4 and 5, because that's 21. That's adds together 12, 4 and 5. But wait a second. If you do x plus 4 times x plus 5, that's going to give you a positive 9x. We need a negative. We must remember, to create a positive 20, either both pieces are positive or both pieces are negative. A negative 4 times a negative 5 does give you positive 20. And since that right there is negative, that tells me, hey, both the pieces had to be negative here. So we can see it's x minus 4, x minus 5. Because negative 4, negative 5, multiplied together is a positive 20. And then when we do this, minus 4x, minus 5x, it does give me the minus 9x right there that I need. So when you have a positive, either both pieces are positive, as we did yesterday, or both pieces could be negative. How do I know? This right here. If it's a negative there, that means both of them had to have been negative. And if it's positive, then they were both positive, just like yesterday.